All right, for page 48 of your interactive notebook, we are going to take the information from class that we learned about multiplicity and end behavior, and we are going to graph a polynomial in intercept form. So one of the things that we want to look for is the x-intercepts. So if I set this polynomial equal to 0, this is truly intercept form. So I can take each of these pieces and set them equal to 0. So negative x squared equals 0, x plus 2 equals 0, and x minus 1 equals 0. And when I do that, I'll end up with 3 zeros or 3 roots, so one of which is going to be 0. That's from the x squared equals 0. We also have x equals negative 2. And then we'll also have x equals positive 1. Now remember, the multiplicity is the exponent on each of your factors. So 0 has a multiplicity of 2. And then both negative 2 and 1 have a multiplicity of 1. And we know because of this multiplicity that the behavior for x equals 0 when it interacts with the x-axis is either going to be a parabola facing up or a parabola facing down. Remember, this is called a bounce or a touch. And then for both x equals negative 2 and x equals 1, they're either going to be some kind of straight line that's going to be increasing or decreasing through the x-axis. So I'm going to go ahead and draw my x-intercepts down there. However, I am not yet going to draw my multiplicities because I'm not sure if this is going to be a parabola facing up or down at x equals 0. And then same thing with x equals negative 2. I don't know if that's going to be a line going up or a line going down. So for right now, I'll just go ahead and graph my x-intercepts, but I'll wait for my multiplicity. Now my y-intercept, you should remember, we're going to simply set x equal to 0. So we don't need to FOIL anything out. We're just going to replace 0 everywhere we see an x. And so when I do that, I end up with 0 squared, which is 0, times 2, and then times negative 1. All of that still becomes 0, so my y-intercept then is going to be 0, 0. I already have that graphed, so I'll go ahead and move on. My end behavior, I need to look at two things for my end behavior. I need to look at my leading coefficient and my degree. In this case, if I were to FOIL all of this out, my degree is going to be the addition of all my multiplicities. So if I add all of these multiplicities, I'll get my degree, which in this case is going to be 2 plus 1 plus 1, which is going to be 4. So my leading coefficient, my degree is going to be 4. And then if I FOIL all this out, my leading coefficient here is going to be negative 1. Because I have an even degree with a negative leading coefficient, I know that my two arms are going to be straight down. So what I'm going to do is I'll go ahead and draw those in. And I'm actually going to go ahead and start graphing this. You could plug in other points like x equals positive 2, x equals negative 3, x equals 7 to get other dots that are going to be on here. But I'm just going to simply go ahead and start graphing without those extra points. This is only going to be a sketch, so this isn't going to have exactly the right points, but it will have the correct x-intercepts, end behavior, y-intercepts, and multiplicity. So as I increase here and I go to x equals negative 2, I now know that this is going to be a straight line going up, increasing through the x-axis because of the way my end behavior was. Now eventually it's going to hit a relative max. I'm not exactly sure where that relative max will be, but I do know that I'm going to have to come back down eventually so that I can go ahead and hit my next x-intercept, which is going to be at x equals 0. And then here I'm going to bounce, which means it's going to be bouncing straight up like a parabola going up. And then again, I'm going to have another relative max, so I have to bring it back down right away almost. And so now I'm going to have a graph that looks something kind of like this. So this should be a smooth graph. I apologize about that jagged edge. So again, this is not perfect, but it's going to be just simply a sketch using the information that I have from my table. Okay, and that problem is now done. I would accept this as full credit for a graph. I'll go ahead and start the next one. So for number 2, we'll start off the same way. This time, this 2 right here does not have an x associated with it, so x equals 0 is no longer one of my zeros, but x equals negative 2, positive 1, and negative 4 are. The multiplicity of negative 2 is 1. There's an exponent of 1 there, even though you don't see it. For x equals 1, the multiplicity is 3, and then for negative 4, it's also 1. As far as my behavior goes, it'll be still straight through for x equals negative 2 and negative 4. But for x equals 1, there's going to be some kind of little squiggle like a cubic function would have at the x-axis for x equals positive 1. So I'll go ahead and draw in my x-intercepts that I have so far. And so now I'm going to find that y-intercept by setting x equal to 0. So if I plug in 0 into the first parentheses, I'll get 2. If I plug in 0 to the second, I'll get negative 1. But then I'm going to cube it. Negative 1 times negative 1 times negative 1 is still negative 1. And then I'm going to get 4 when I plug it into the last one. 2 times 2 is 4. Times 4 is 16. Negative of that is going to be negative 16. So my y-intercept then is going to be 0, negative 16. So I'm going to count by 4s here on the y-axis so I can get all those in. So this is going to be counting by 4s here. So I'm going to graph negative 16 at this dot right here. So this is going to be negative 16. Now for my end behavior, I'm going to add those multiplicities up. So 3, 4, 5, that means I have a degree of 5. And because of that degree being 5, I know it's going to either be opposite. They're going to be in opposite directions. And if I FOIL all this out, 2 will be my leading coefficient. It's positive, so now I know that it's going to follow positive x cubed because it's an odd degree and a positive leading coefficient, which means right arm up and left arm down. So I'll go ahead and add that to my graph. And this is enough information to at least just start sketching. It's not going to be a perfect graph, but it's enough to get me full credit on my quiz or test. So I'm going to start going up from the bottom arrow. When I get to x equals negative 4, I'm going to go straight through. I'm going to come back down. When I get to x equals negative 2, I'm again going to go straight through. And then I'm going to go down, down, down. I'm going to have a relative min eventually, so I'm going to start to come back up. Now this is going to be the weird part here. At x equals 4, there's supposed to be a squiggle. I'm sorry, x equals 1, there's supposed to be a squiggle. So what I'm going to do is I'm going to go ahead and make that squiggle happen right now. Because this is increasing, I know that I'm going to have a going up squiggle. And the way that I would say to do that is make a parabola facing up on the right-hand side of x equals 1 and a parabola facing down on the left-hand side. So now when I connect those pieces together, it's not a perfect squiggle, but you can tell that it's going to be like a cubic function. And this would be sufficient to get full credit. Even though I didn't attach to this end arrow here where I first originally had it, that's quite okay. I can move that arrow and I would delete that other one. So I don't need to have the original arrow there. And that's all we'll do for our notes for today. I'll go ahead and do these 2 examples in class. So that'll be all for page 48 for now.